Today I'm going to show you how to make an interior design transformer using Comfy UI. What is an interior design transformer, you might be asking? Well, it is exactly what the name says it is. It is transforming the interior design into something else. And how are we doing that? We're doing that with AI. We're taking a reference image, something from the internet, and then redesigning our bedroom layout with that reference image. So if I were to show you, this was the base image of my room. If only I had such a good bedroom. And this was the example of a contemporary design I've taken off Google. You can find many. And combining these two, you see the final image is an exact replica of my room, but in a reimagined design. Let me show you a few other examples of my transformer results. You've seen the contemporary one. Here's a minimalist bedroom design. As you can see, it looks very neat, very simple. Here's a Scandinavian bedroom. As you can see, the base image I used was pretty bad with the quality being not so good, but it still reimagined a good interior design. Here's another example I really like, which is the Indian traditional. This one looks really good. And trust me, Comfy UI and the workflows that allow you to create something like this is just amazing. All right, hold your horses. I'll show you exactly how I got this done. I use a tool called Comfy UI. This is an open source software that allows you to create workflows to do amazing things with creating images, videos, and a lot more. You can read up more on their website. Now I'm running Comfy UI in the cloud through something called as JavaSlabs. Just go to javaslabs.ai and create an account. Make sure you add enough money into it because running things in the cloud costs some money. Go to create instance, click on Comfy UI, and run on cloud. Now I'd recommend choosing the A6000 model because it has a good CPU, RAM, and a VRAM for running this particular workflow, and you can set the storage to something like 100 GB, which should be fine. You likely have to download a few extra control nets and then just launch the instance. Now I'm not doing that because I already have an instance running, so make sure you have an instance before you start. Alright, this is where the magic happens. So let me walk you through this workflow that I've created. You have a load image node, which is to take in your input. You have a load checkpoint, and the checkpoint I'm using is the Stable Diffusion 1.5 model, particularly Juggernaut. If you don't have it, you can always go to Model Manager and install it. And let's see what else is there. All right, we have an IP adapter, a control net. And the control net, essentially what it does is it pulls information out of the base image, like what you see here. I've used this model called MLSD lines. You can search for it in the control net name, MLSD. If you don't happen to find it here, you can always go install it from the model manager. Just click on manager, model manager, and then search for the string MLSD. You should be able to find it here, control net v11 MLSD. Just install it and make sure after you install it, you restart your Comfy UI instance. Only after you restart it will you be able to actually use it. Now, coming back to the flow. In our control net, you can set the MLSD, and this is how the preview of the output looks like. It essentially pulls the layout information, the straight lines, from your base image. Now, the IP adapter. The IP adapter is used to extract the style from the base image. In this case, it's extracting the interior design styles from the image you've uploaded. You can just come to the load image node, select what image you'd like to upload. It comes over here. Make sure in the IP adapter unified loader, you select the preset of SD 1.5 only. This is the one that's compatible with the SD 1.5 model. And essentially, this entire segment here is responsible for extracting style information. Now, all the outputs of the control nets and the IP adapter, you see, goes into our K sampler. The K sampler here can be thought of as a magic cooking pot that takes the inputs from both the control net, the IP adapter, and the clip text encode prompts. As you can see, I've added a positive prompt here, which is an ultra-realistic interior photography. I needed to add this to make sure that the final output adheres to a photography of the interior design. Of course, we have the empty latent image, and I've noticed that the sampler name that we use here works well with the DPMPP side GPU. I've tried with a bunch of other sampler names and I get slightly different results. This is one that I like best, so I'm going to stick with this. Now, if we were to stop here, you'd get a pretty decent response, and this is how it looks. But if you look at it, this image looks a little bit grainy, looks a little fake. When anyone looks at it, they can immediately tell that, hey, this is an AI generated image. Now, if you want even better results, we'll have to upscale it. And how do we upscale it? I recommend using the upscale latent method. How do you do this? You can just add an upscale latent by, select bicubic as your method, maybe you scale it up by 1.5. Of course, you need another K sampler. And one thing I've noticed is that you got to keep the denoise to less than 0.5. And whenever you upscale an image, it fixes any weird bugs that you might see in the base image. This is how a final image looks like, and this is so much better than the initial image we generated. If I were to do a side-by-side comparison, you can actually see the differences. Let me zoom in. You can see the image to the right was the first generated image, not too great. The photograph over there seems a little weird, doesn't seem too realistic. How about I reposition this? All right, so we have a before and an after. As you can see in before image, the painting is not too well made, but there's a lot more detailed. The lighting seems a bit off, and the lamp to the left, too basic. All right, now that we got the complex parts done, let me try to break it down in a much simpler way. So our objective is to transform interior spaces by applying different design styles by keeping the room structure intact. This is the base image we're going to use, and we're going to reimagine it into different styles. Here's exactly what I did. We started off with the base image. This base image is going to be same for all the flows we do. Now with this base image, we're going to pass it to a control net. Now which control net do we use? We use this thing called MLSD lines. Remember, this was important for extracting the layout information from the base input image. How does that look like? Here it is. This is exactly extracted from the image. It only pulls out the straight lines, and this information will be passed later to our K sampler. Remember what K sampler was? This was your magic cooking pot. This is where all the ingredients go. Now, parallel to this flow, we're going to create another one. We take in a reference image, and I'm going to use any basic image pulled out of Google for this. You just need a bedroom interior design layout, and what you're going to do is you're going to extract information from this using an IP adapter. We use the IP adapter to actually extract the style information from your reference image, and it passes all of this data to the K sampler, your reference image style data. Now, along with the control net data using MSLD lines, your IP adapter, all of this go to the K sampler, and of course, we need to use our base diffusion model. For this workflow of ours, I use the SD 1.5 model along with the positive and negative prompts and of course the latent image. I'm not going too much into depth here because that is basically the starter template you start off with when you open your Comfy UI instance on JavaSlab. Alright, once you've added all this information to your K sampler, you can then go ahead and generate an image. The first image you generate from SD 1.5 won't be too great to look at. I mean, it's alright, but in 2025, if anybody looks at that image, it's almost obvious that they'll tell you that it's an AI generated image. The final thing we need to do is to upscale it. And how can we upscale it? We can upscale the latent. When you pass in the stable diffusion generated image up to an upscaler, you get a final upscaled reimagined image. Now this is where the true beauty lies. If I were to show you, it looks something like this. Ooh, magnifique, perfect, such high detail. If I were to compare it side by side, you can tell the amount of detail that's been added because of the upscaling process. The reason why the final image looks like our base image is because of this, because of the layout info that got extracted by the control net via the MLSD lines. Now, to summarize, we had a base image. We use control net with MLSD lines to extract the information. We used an IP adapter to pull out the style information from a reference image. We passed all that data to the K sampler along with the SD 1.5 model. All this gives us the first generated image, which we later upscaled to get a final image. Here's a summary on the Comfy UI workflow. We had three major pieces: the IP adapter that extracts the style information from your reference image. We had the control net, which extracted the MLSD lines for the layout of the base image. And we have the upscale latent workflow, which's job was to just upscale the final result. Once you have all this, you can go ahead and build your own interior design transformer. Just to show you the final designs once again, I have 5 different transformed designs. One is contemporary, you have a minimalist, you have a Scandinavian. Even though the base image was quite bad, Scandinavian came out pretty well, I guess. An Indian traditional, and a Japanese style. Now I'll leave a link to all my Excalibur images and the final generated output. You can find all of this on my GitHub. That's it. Have fun.